Alright, solution of trigonometric function 7.3. There are 7 points that you need to know as seen in the slide. This is point number 1. Point number 2 is about the solution angle. Point number 3 is about the solving the trigonometric equation in the form of a cos theta plus b sin theta equals to c, a number. So there are two methods, either using the t substitution or r sin r cos. So number 4 is just the how to use the substitution method. Point number 5 here is how to use the r cos r sin method. And point number 6 and 7 is about the maximum and the minimum value for sin theta, which equals to 1, and the minimum value which equals to -1. Alright, let's see example 7 here. Okay, so now we are going to solve a trigonometric function. This is just a linear trigonometric function. So the 5 points that you need to know in order to solve a trigonometric function is Q, B, this. Q is for quadrant, B is for basic angle, D is for draw, I is for interval, and S is for the solution. So let's see the first example, cos theta equals to sec 3 over 2. Its quadrant is 1 and 4. Why? Because cos is positive at quadrant 1 and quadrant 4. B, the basic angle. So to find the basic angle is just shift cos square root 3 over 2, which equals to 30 degrees. So 30 degrees here is your basic angle. Its interval, so we check back the interval that the question 1 is between 0 to 360. No problem because our basic angle here is theta. So we don't have to modify the interval. Next is to draw. Drawing is very important so that you know that your quadrant must be in the first and the fourth quadrant, and the basic angle that you have is 30 degree. So when you have this drawing, you can definitely find the solution, which the solution in the first quadrant is just 0 plus 30 degree, which is 30 degree. And the solution in the fourth quadrant is just 360 minus 30 degree. You can refer to point number 2 in the first slide. Okay, next question B. We have sine 2 theta equals to half. First, we have to find the basic angle. So remember, the basic angle here is 2 theta. Don't change it to theta. We don't want theta. We want 2 theta as the question mentioned. So our basic angle here is 30 degree. And when we draw, we know that sine is positive in the first and the second quadrant. So it will be 30 degree for the first solution and 180 for the second minus 30 for the second quadrant. But then this basic angle is 2 theta, so we have to modify its interval. Its interval is between 0 to 720. Why? Because we have 2 theta instead of theta here. And then for 2 theta, the value is 30 degree, 150 degree, for the first and the second quadrant, but we have to add another 30, 160 degree for the second cycle. So that's why we have 4 values of solution here. And again, we don't want theta as the final answer. We want theta, so we divide everything by 2 to get the final answer. And last one, for tangent theta over 2 again, we have to find the basic angle, but the basic angle here, remember, is theta over 2. So theta over 2 equals to 45 degree. And since the basic angle is just theta over 2, so we have to modify our interval. Instead of theta, it's going to be theta over 2. So it's just between 0 to 180 degree. So that's why in our drawing, it's just in the first quadrant. We cannot take the solution in the third quadrant because it's out of the range, because it's more than 180 degree. So the final answer that we have is theta equals to 90 degree. Alright, so look at the next example. Example 8. Now we have a quadratic trigonometric function. Example 7 just now, it's a linear trigonometric function. So this is a quadratic trigonometric function. We can easily find the factor using the calculator. Just press A equals to 1, B equals to -3, and C equals to 2. Then you will get the factor. Tangent theta minus 2 and tangent theta minus 1. So we have to solve tangent theta equals to 2 and tangent theta equals to 1. So this is the two things that we need to solve. And then the next thing we are going to do is finding the basic angle. So here is the basic angle for the first solution. This is the basic angle for the for the second solution. To write the basic angle is very important because this will give you the marks for finding the basic angle. So the next thing that we need to do is to draw in which quadrant that the theta lies. So since tangent is positive, the theta lies in the first and the third solution, the third quadrant, sorry. And also here theta is positive, so the solution lies in the first and the third quadrant. And we write the basic angles that we have, 63.4 and 45 for the second solution. Then we will get our solution. Since the theta is between 0 to 360 and our basic angle is also theta, so there is only one cycle. So this is the first answer for the first solution. This is the second answer for the second solution, and the final answer is just combining all the four answers that we get from both of the solution. Alright, we move on to example 9. Example 9 here we show you how to solve the trigonometric equation that equals to a number. So there are two methods of doing it. It's either using the t substitution or using the r cos r sine. So is this example 9 here, we are going to use this t substitution. I just put back this one as your reference, but you can find this in the first slide of 7.3. Alright, so the question asks you to let t equals to tangent theta over 2. Show that tangent theta equals to 2t over 1 minus t squared. So that is what we're going to do here. We let t equals to tangent theta over 2 as the question said. And we are going to use the double angle or the half angle formula, which we know that from the double angle formula, then tangent theta equals to 2 tangent theta over 2 over 1 minus tangent squared theta over 2. Don't worry, this is in the formula itself. We let just now t equals to tangent theta over 2. So that's why it's here, tangent theta over 2 will become 2t. And tangent squared theta over 2 here, it will become 1 minus t squared, because we let tangent theta over 2 here equals to t just now. Whenever we have this tangent theta, we can always draw its right angle triangle. This right angle triangle here, 2t is the opposite and 1 minus t squared is the adjacent. We can easily find its hypotenuse, which is 1 plus t squared. So when we have a complete right angle triangle here, we can always find its sine theta and also cos theta. So why we need to find the sine theta and cos theta in terms of t? Because we are going to use it to solve the equation that the question asks you to solve just now. 3 cos theta plus 2 sin theta equals to 3 by substituting the value of cos theta and sin theta in terms of t, like this. And you can get a quadratic function in terms of t. Then you will solve t value to get 0 and 2 over 3. But the question don't want you to find t. The question asks you to solve the equation, meaning that it wants you to find the value of theta. So finding the value of theta, you change back t equals to tangent theta over 2. So you will have tangent theta over 2 equals to 0. And also tangent theta over 2 equals to 2 over 3. You have two equations that you need to solve for theta over 2. Finding the basic angle for both of the solution, and you will get the answer for theta over 2 and theta. Alright, as I said just now, there are two methods of solving the equation that equals to a number, like this. So it's either using the substitution t that we did in example 9 just now, and also we can use this method, which is we call it r sine or r cos. So I just put it here as your reference, but you can find it in the first slide of 7.3 just now. Okay, so the first question said express 2 cos theta plus 3 sin theta in the form of r cos theta minus alpha. So we just write back in the mathematical form like this. And you know, we can always use the compound angle to expand this to get something like this. We just use the compound angle. And then as you can see, this left hand side we have cos theta, and the right hand side also we have cos theta. So we can compare 2 with r cos alpha. And we also have sine theta in the left hand side, sine theta in the right hand side. So we will have 3 equals to r sine alpha. So we have first equation and the second equation like that. Okay, so in order to solve to get the value of r and alpha, first we will add the first equation and the second equation like this to get the value of r. And also we can divide equation 2 by equation 1 to get something like this to get your alpha. So now you already have your r and alpha. So what we need to do is to express the equation in terms of r cos theta minus alpha as the question asks you to do. Okay, so now you already express the equation in terms of r cos. So the question said, hence solve the equation. Solving the equation, we don't use the 2 cos theta plus 3 sin theta because we already express it in the form of r cos theta minus alpha. So we just write back r cos theta minus alpha just now, which is equivalent to square root 13 cos theta minus 56.3 equals to 1. Okay, square root 13 can bring to the right hand side and you will get the basic angle and solve normally to get the value of theta. Okay, in this example, we are going to find the maximum and minimum value for an expression and also to find the value of theta for which the expression has the maximum and the minimum values. So what we need to do to find the maximum and minimum values for the expression, first, we have to change it to the form of r cos or r sine, like we did just now in example 10. So finding the value of r and finding the value of alpha. And we can express the expression in terms of r sine theta minus alpha like this. Okay, as I said just now in the first slide, the minimum value of sine theta and cos theta is -1 and the maximum value of the sine theta and cos theta is equals to 1. So its minimum when sine is equals to -1. So we can find the value of theta when we solve this equation. And we can also find the value of theta for maximum when we solve sine theta equals to +1. Alright, here is the exercise for you to try on by yourself. And all the best.